this surveying arm, if you see, next, surveying arm has a provision over here to attach something. So surveying arm has a provision of attaching what? Surveying tools. Now there are various tools of surveying, right? You cannot just do surveying by these all parts which we saw right now, right? See, surveyor comes as a 10 marker question. So where you will have to start with the intro, definition, objectives, various parts, the diagram, the explanation of the parts, and then moving on to the surveying tools. So if I talk about the first and the foremost surveying tool is the analyzing rod. So what is analyzing rod? It is a thin metallic circular rod, and the name again itself is saying you that it is only to analyze. It is an analyzing rod, right? So it is only used to analyze the contours, the prominences and the structures of the intraoral region while you are designing or planning and cast partial, removable cast partial denture, right? So the main function of analyzing rod is what? To analyze. Now how does this analyzing rod work? So when you place this analyzing rod on the most convex surface, you see this area, this white area, that white area is called undercut. Okay. Now in this undercut only your clasp assembly goes and engages. You always think, right, where to place the clasp, how to fabricate a clasp. In your normal acrylic partials also, you always try to place the clasp below the most prominent area. It goes and engages there. So when it has to lift back up, it doesn't come out easily. The clasp has to flex according to the contour of the teeth and then come out, right? And then again the flexion, the flexibility of clasps also varies. If the length of the clasp is more, it will be more flexible. If the length of the clasp is short, it will be less flexible. Similarly, if the diameter of the clasp is more, it will be less flexible, and the diameter of the clasp is less, it will be more flexible. So it is vice versa. So the length of the clasp is directly proportional to the flexibility. Okay, this is an additional information. Length is directly proportional to flexibility, but diameter is inversely proportional to flexibility. So in simple terms, analyzing rod is used to analyze the height of contour of the teeth and the associated structures, right? So when you have the analyzing rod, you can use this to analyze all the areas, right? And then you can move to your next surveying tool. So when you are thinking of using or doing surveying, it is done in this order only. The first instrument what you use is the analyzing rod. So once you have analyzed all the areas, now you have a picture in your mind. Okay, if I am fabricating a Kennedy's class on RPD, what is Kennedy's class on RPD? It is bilateral edentulous area on both the sides of the midline. Correct? So the abutment teeth for Kennedy's class 1, suppose we have both the second molars missing in mandible. What will be the abutment teeth? The second premolars on both the sides becomes the abutment where you place your clasp. And it's not such that you only check the abutment teeth, you have to check all the teeth, because sometimes some teeth might be more tilted or it might be wrongly placed in the arch, which might affect the design of your denture, right? So you should not stick to just delineating or analyzing the contours of abutment teeth, but also visualize other teeth and the structures around that teeth, so that they don't influence or affect your design of removable partial denture. Correct? So this is about analyzing rod. The second important tool over here. Now you have analyzed. The picture is in your mind कि हाँ premolar पे this much undercut, इस side premolar पे this much undercut, this area the teeth is more inclined, so there it might affect. but what and how to bring that picture on the cast. So to bring that picture on the cast, you have a similar structure like analyzing rod, that is your carbon marker. You have used your pencil, right? Normal carbon pencil. If you remove all the wood around that pencil, what you see? A thin lead of carbon, cylindrical, right? Similarly, like analyzing rod, you have a thin cylindrical lead of carbon which gets fit into the surveying arm. And same as you analyze the contours, again you analyze the contours, but what will be the change? The change will be that the markings will be produced in the most prominent part of the teeth. So when you kept the cast, you kept it, the arm is always parallel, right? So when you run across all the teeth, whichever area is most prominent, that area will be marked automatically. So what you are marking? You are marking some lines on the cast. To be precise, what are these lines called? They are called survey lines, because you are doing surveying with what? With a surveyor. So the lines which you will draw will also be survey lines, correct? So carbon markers are what? It are similar to the lead points which we see in the pencils. They are circular in cross section. Okay, see, some surveyors may have circular cross section of the carbon markers, some may have triangular cross section also. We have triangle pencils also, right? Dom's company, if you have remember in your childhood, we have triangular pencils, whereas Apsara or Natraj, they have a circular ones, right? So triangular carbon markers are seen again in Jelenko, circulars are seen in Nays. Okay, so Nays surveyor and Jelenko's surveyor. So this is about your carbon marker. Now you mark the line on the most prominent part. Below that prominent part, all the area is called undercut, where your clasp assembly is going to go and engage. But if you want to measure the depth of that undercut, okay, so for measuring the depth of that undercut, what you need is the undercut gauge. Okay, depth gauge or undercut gauges. Okay, so undercut gauges are what? Again, a cylindrical rod with an extension of different diameters, 0.01 inch, 0.02 inch and 0.03 inch. Okay, so all these three types of diameters are extending outside from that circular rod. Okay, this is mostly in your Nays surveyor. You have three different depth gauges, whereas in Jelenko's you have a single rod where you have three different dimensions, right? So again, see, manufacturer's design. It was Jelenko's idea of giving 3 in 1. Nays wanted that I want separate, right? So it doesn't matter. The concept is what? Key, when you have marked that line, now you want to measure the amount of curvature beneath it. What is the depth of that undercut? So what you do? You align the surface of the rod with that line. And then you see whether this pointed part of extension of that gauge is touching the teeth or not. You have to change and see till it touches the teeth. So the line should touch the rod, line will touch here. Okay, so suppose if I zoom in and show you, okay, this I have placed it over here. So now when this is touching over here and this is touching over here, this area I can tell that this undercut is of 0.01 inch, hypothetic, right? Similarly, it can be of 0.02, 0.03, not more than 0.03. Because if you have an undercut of more than 0.03, it is advisable. Suppose you are keeping the cast flat, 0, right? Over here, if I will show you with a diagram, two different diagrams I will draw. Okay, now the undercut over here is suppose 0.03. How can I reduce the undercut Don't say, sir, trim this surface so the undercut will go. We are not here to damage the teeth. If I tilt the teeth like this, okay, if I tilt the teeth like this, now the undercut is gone, correct? Because this here the root will come. Understood? So that is where the tilting feature of the cast holder is very useful, because if you tilt the cast, one side of all the contours will change and the other side of contours also will change. So if you feel that the undercut is more pronounced, or if there is no undercut, suppose this is one situation where I have eliminated the undercut. Okay, now I want to create a more undercut. Suppose this undercut is of 0.01 only. I want a 0.03 ka undercut. So what I can do, I can tilt the cast this way. So when I tilt the cast or teeth this way, so now this area is increased, right? So this becomes a 0.03 undercut. So based on the depth of the undercut, you determine which type of clasp you are going to put in that RPD. It is not always a C clasp like an acrylic partial denture. No. When we talk about cast partial denture, we have different types of direct retainer, or you call clasp. Okay, in simple terms. Those different type of clasps are used in different clinical scenarios. It is not as simple as acrylic partial denture. So the whole concept of determining the height of contour, the depth of the undercut, is to determine the parts, which part you are going to use where. If you use which part, which will be efficient. That is why you are doing all this, right? This much you don't do in your acrylic partial denture, because after curing also, if the clasp is not adapted, what you will do? You will take a universal plier, bend it, now it is sticking to the teeth, happy, patient happy, doctor happy, over. But it doesn't work like that in your cast partial dentures. In your cast partial dentures, you have to plan, because you are casting it. You cannot repeatedly cast again and again. It is not an easy process, right? Nowadays we have CAD CAM and digital designing over there, right? So nowadays you design the prosthesis or the design of an RPD in the software. You directly press enter in the computer, it goes to a metal sintering device or a milling machine. There the metal itself will get trimmed according to the design and you can get it very quickly. Before, initially it was casting, but still metal trim, the milling of the metal also takes time. Okay, so that is the whole concept of your surveying. That is why you are doing surveying, to design and decide the parts of RPD. Lastly, once suppose you have made a wax pattern, now if you want to increase or decrease the undercut, but you don't want to change the tilt. Okay, for you the tilt is perfect, but after fabricating the wax pattern you feel that I want to slightly change. So what you have? You have a wax knife. Okay, so you have wax knife. So now when we talk about wax knife, it has a sharp bladed surface on one side, which will help you to contour the surfaces of the wax. Any excess wax or any area which has to be modified or recontoured can be done using a wax knife. So this was a very simple and a good explanation about surveyor, okay, parts of surveyor, and then different tools of surveyor. Okay, now when we talk about two different common types of surveyor, right? Two different common types of surveyor I have been telling you from before. Sometimes you might be asked in your exams also, right? So the first is the Ney surveyor, the second is the Jelenko's surveyor. So when we talk about the Ney surveyor, horizontal arm is fixed, right? You can see the horizontal arm which is fixed over here. There is no joint present in this area, whereas there is 1, two joints present in the Zelenko surveyor. Vertical arm is retained by friction. Okay, the retention mode of the vertical arm is through friction. Over here you have a knob, you put it down and again lock the knob, whereas over here it is spring loaded. Okay, because if you release, it will return back to its original position. Here the cast table or the cast holder you can move all around the platform because it is not fixed. Why the cast holder is not fixed? Because here you don't have a flexible attachment. See, one attachment has to be flexible. Either the horizontal arm will have some provision of moving in all the directions, or the cast holder has to move in all the directions. Both will not move. One will be fixed. In Naze surveyor, the cast holder will move all around, but the horizontal arm will move only left and right like this, because in between there is no joint. Whereas if you talk about Zelenko surveyor, in the Zelenko survey you have a junction over here where you can, it's like our elbow, so one part and second part, so from here also you can move and from here also you can move, understand? Okay, but the cast holder will be fixed, you cannot move the cast holder. Okay, so that is a brief description about the difference. These are the various types of surveyor designs. If you see, this is Naze surveyor, second is Wills, third is your electronic, then you have a stressograph, you have a broken arm surveyor, laser, then Galoni isoparallelometer, Bachmann's parallelometer. So these are different. You can use these 4-5 names so that you can show the examiner that you are also aware about other types of surveyor also. Correct? That is about surveying. Okay. Now the next thing which we'll study in the next coming topic is your survey lines, right? Survey lines will be taken in the next class. So again, to brief out and revise the parts of surveyor or what is surveying, right? So first you will write the introduction, the definition of surveying, the definition of surveyor, the objectives of surveying, then the various parts, surveying platform, cast holder, vertical arm, horizontal arm, surveying arm and surveying tools. Correct? Then you can illustrate the difference between the Naze and Zelenko surveyor, right? Draw the diagrams, it will fetch you an additional mark, right? Then you can name out different types of surveyors, and the next topic is the survey line, which we'll discuss in the next class. So I hope you guys have understood what is basically a surveyor and what is basically surveying. Now I told you, right, we are marking some lines with the carbon marker. Those lines are called survey lines, which we'll discuss in the next class. Thank you so much. Have a nice day.